Okay, let's figure out how to find the equation of a cubic function when you're given a graph and some points. And how do you do that? Well, in grade 11, we learned this thing where we were given a point, say like 0 and minus 6. Maybe we're given some other points, like intercepts. Well, there was a way we figured out parabolas doing that. Let's just see. We've got this equation. We're given a couple of things. Let's see what we're given. If a point lies on the graph, then it must make the equation of a graph true. That's an important thing, okay? So you can substitute it into the equation. At a stationary point, if you've got a turning point, we know that the derivative, f prime of x, is equal to 0. Those are two big ideas. We often have to solve simultaneous equations. So you use these two ideas to build two simultaneous equations. Now, the following examples, Mr. Audrey says they're not exhaustive. That means they're not every possible question that can happen, but they can help you to explain these ideas. And it's really about knowing functions that make it easier for you to do these questions. Okay. Well, say you were given this. You were told that this green thing here is a function, f of x, and it's a cubic function. But we don't know a, we don't know b, we don't know c or d. But we do know the line, g of x equals 6x minus 6. How could you figure out a, b, and c, and d? Well, it says here, we're lucky that we were given this point. You could have found that point, the y-intercept, just by letting x equals 0. Then y would be minus 6, and then we'd just have that point. But we could have found it just by letting x equal 0. Well, now we've got all this stuff. How do we get started? Well, let's see here. Looking at the sketch, we see we've got two intercepts here. And here's an important trick. Because it turns right on this x-axis, if minus 1 makes y 0, then x plus 1 must be a factor. It must make it true. And if it turns on here, it must be x plus 1 squared. X plus 1 times x plus 1. It turns on 3, so it must be x minus 3. Well, that's how we get started. There's the equation. And just the turning point on the x-axis repeats itself. The factor repeats itself. X plus 1 times x plus 1. Okay, moving right along. We know that it goes through 0 and minus 6. So we can take x as 0 and y is minus 6. And instead of x, we put it 0 wherever x is. See, we're using this other equation that we just figured out. And wherever we have y, we put in minus 6. Right there. And then, okay, this is just going to be 1 times, it's just going to be minus 3a. Divide by minus 3, a must be 2. And then all we do is take 2 and put it back into the equation. Put a 2 back in there. And 2 times x plus 1, you just got to multiply this out. X plus 1 squared is x squared plus 2x plus 1. And then you have to do x multiplied by everything and minus 3 multiplied by everything. You're going to get an x cubed, you're going to get minus 3x, you're going to get 1x, and then minus 6x, that's minus 5x. You're going to get 2x squared, and you're going to get minus 3x squared. That's minus x squared. Then you have to multiply everything by 2, and there's your final answer. There, we've got everything there. A is 2, B is minus 2, C is minus 10, and D is minus 6. And there you go.